Hello students and welcome back. So today we will be learning lesson 11.1 and 11.2 because they share similarities. Today's objective is I will relate angles and fractional parts of a circle. That is our objective for lesson 11.1. Make sure to write that down. Let's look at the circle. In the circle, we can divide it up into fractional pieces, 1/2, 1/4, and even into 12ths. Now what does this remind you of? If you said it reminds you of a clock, nice job. A clock can also be divided up into 12 parts. Think of time. It goes into all the way till 12 o'clock. Now we're going to take a look at how we can relate that to fractions of a circle. So if we give each turn a number and we say the arrow has moved from the 12 to the 3, what fraction of the circle has it covered? We could say it has covered 3/12 of the circle, and if we simplify that, we could say it's 1/4 turn. Notice the part that is covered here, the part that the arrow has moved, would represent 1/4 if we shaded that in of the entire circle. Now we have to figure out, has it moved clockwise or counterclockwise? So I want you to remember when you put your hands up like this, if you drop your right arm around, that is clockwise. Now, if you use your left arm, that is counterclockwise. That is going the opposite direction. Clockwise is the way the hands move on a clock. So thinking it counts towards 1, 2, 3, and it goes up. Counterclockwise is going backwards, which means it would count down. So we would say this is 1/4 turn clockwise. Now on your notebook sheet, you have 4 different circles. You may choose to fill out any of those 4 circles with the next following slides. What fraction is the turn? Clockwise or counterclockwise? Let's find out. So we're starting at the 12, and the other arrow has moved down to the 6. What fraction is this turn? First, let's talk about it as 12ths. It has covered 6/12 of the circle, and if we simplify this, it is 1.5 turn. Now, is it moving clockwise or counterclockwise? Remember to use your hands. Did the right hand move or did the left hand move? The right hand moved, it turned clockwise. Let's practice again. What fraction is the turn, clockwise or counterclockwise? So we're starting at the 9, and now the arrow has moved to the 8. First, what fraction of this circle has turned? This is 1/12, just one piece of the circle. Now, has it moved counterclockwise or clockwise? Think of using your hands. It is moving 1/12 turn counterclockwise, meaning it went from the 9 to the 8. It went down instead of going up in numbers. Let's practice again. What fraction is the turn, clockwise or counterclockwise? We've gone from the 12 to the 6, going the other direction. So first, what fraction of the turn? It has covered 6/12. This can be simplified as 1/2. Notice if we covered this part of the circle and shaded it in, it has moved 1/2 of the circle. Now counter or clockwise, it has 1/2 turn counterclockwise. Remember, it is moving by going down in number, not going up. Let's practice again. What fraction is the turn, clockwise or counterclockwise? Starting at the 12 and moving down to the 9. First, we can recognize that 3/12 of the circle has been shaded or moved down. This can be simplified as 1/4 turn. Notice it is 1/4 of the entire circle. We would say this is 1/4 turn counterclockwise because it is moving down in numbers. Now we're going to move to lesson 11.2. Our objective for 11.2 is I will relate degrees to fractional parts of a circle. Let's review. Remember, there are 4 types of angles. There is a right angle, there's an obtuse angle, bigger than 90 degrees, a acute angle, smaller than 90 degrees, and a straight angle, which is exactly 180 degrees. What is a degree? A degree is a unit to measure angles. I know what you're thinking. A degree is to measure temperature. We also use it to measure degrees of an angle. How many degrees are in a circle? Well, if you remember, if you spin all the way around, or if you can do a complete backflip, you are doing a 360. That means you are turning all the way around or in a complete circle. What is the measure of an angle in degrees? So if we look at this part of the circle, how much of the circle is being measured? Well, we can relate it to fractions. We see that this is 1/4 of a circle. And if we have 360 degrees to make a full circle, we can divide that by 4, meaning there'd be 1, 2, 3, 4 pieces that would make up this entire circle. So 360 divided by 4, we can use our knowledge of our zeros here to know that 4 goes into 36 9 times, and then we carry over the 0. So 360 divided by 4 is 90. So what I can do is multiply 1/4 by 90 and 4 times 90 to equal 90 over 360. Simply, this is saying that the whole circle is 360 degrees, and the angle that I'm showing you is 90 degrees of that 360. It's a part of it. So we'd say it's 90 out of 360 degrees, so it is 90 degrees. If you also recognize this square right here, you would have known it's 90 degrees from the very beginning. What is the measure of the angle in degrees? So let's see, we can look at this, and knowing our knowledge from 11.1 that this is a part of a circle, 1/12, we can know that the circle is 360 degrees, and to find just a part of it, we'd have to divide by 12. How many times does 12 go into just 36? 3 times, and then we carry that 0 over. In other words, 360 divided by 12 is 30. What this means is this angle here represents 30 degrees of the 360 degree circle. So right here would be measured 30 degrees. Let's practice again. What is the measure of the angle in degrees? So we have to use our numbers along the side to see 1, 2, 3, 4. This is going to be 4/12. So we know each 12th is 30 degrees from the last one we just did. So 4/12 must be multiplied by 30 to find the total. 4/12 times 30 is 30 times 4, gives us 120. That tells me that this right here is 120 out of 360 degrees. What is the measure of the angle in degrees? Ooh, we got a straight line here. So we could represent this as the fraction of 1/2. We know that the whole circle is 360. Now, if we divided it just into 2 different pieces, we know that each side of this circle would be 180 degrees. We could also know that because if we know that a straight angle measures 180, we know that this is 180 and the other side is also 180. Multiply 1/2 by 180. And what this tells you is this angle here is 180 degrees of the 360 degree circle. So it's 180 degrees. Okay, let's see what we can do in finding out the measure of the angle in degrees when given just the fractional part. So if we're given the fraction 50 out of 360, the measure of the angle in degrees would be 50 degrees, because this fraction right here is telling me that this angle is 50 out of a 360 degree circle. Let's try that again. So if they give us the fraction 150 out of 360, what is this telling you the measure of this angle is? If you said 150 degrees, good job. Remember, the circle is 360 degrees total. this angle measures 150 degrees of that circle. Let's try it again and see if you can get it before I do. So this fractional part is 10 out of 360. So what would the measure of this angle be? If you said 10 degrees, nice job. Now what can we do if we're given a fractional part that isn't in 360? Well, what we need to do is use our previous knowledge of equivalent fractions to multiply to equal out of 360. So we have to think of how many times do we need to multiply 15 to get 360. In this case, if we multiplied 15 by 24, we'd get 360. So what we do to the denominator, we must do to the numerator as well. So 1 times 24 would equal 24. So this tells me 1 out of 15 is equal to 24 out of 360. Nice job today.